Today we're going to learn about some special cases for two-step equations. Let's look at one that is a normal two-step equation first. So here we have x divided by 3, subtract 5 equals negative 3. So we always start out by drawing a line down the middle, and then let's identify what's being done with our x. So this part attached to the x is x divided by 3. So we're dividing x by 3 here. And then the other portion that we have is a minus 5. So we're subtracting 5. Remember, when we're solving for an equation, we're trying to get the x by itself. To do that, we need to cancel out the divided by 3 and the negative 5. We use inverse order of operations, which means that we get rid of the minus 5 first. The opposite of subtracting 5 is going to be to add 5. When I add 5 to this side, it'll make it 0 and get rid of one of the numbers. But if I do that to this side, I have to make sure to do it to this side as well. Once I've added 5 to both sides, I want to simplify. I simplify on both sides to see what I have left. Now that this is canceled out, it makes it 0. The only thing left on the left-hand side of our equation is the x divided by 3, which we can bring down. On the other side of our equation, we have to bring down that too. We had negative 3 plus 5. When we bring that down, we get positive 2. And we make sure to bring down our equal. Now, it's not done yet because we still have to get rid of the x divided by 3. So to get rid of division, we do the opposite. The opposite of dividing by 3 is to multiply by 3. I'm going to indicate multiplication by using a dot. That way, I don't get it confused with my variable. So times 3 to both sides. It's our second step. That cancels out the division, and now we can bring down what's left. On the left-hand side of our equation, our x is now by itself. We got rid of the 5 and the 3. On the right side, we have 2 times 3, which is 6. So our answer is x is equal to 6. To check my answer, I can plug it back in for x at the original equation and see if it's actually equal to what it's supposed to be. So instead of x divided by 3, I can put 6, our answer, divided by 3, minus 5 is equal to negative 3. And let's check and see if that's right. So 6 divided by 3 is 2. 2 minus 5 is in fact equal to negative 3. So our answer must be correct. So our normal two-step equation, cancel out any adding and subtracting, cancel out multiplication and division. Now let's look at a special case. This case looks a little different. You might have noticed that it has the x included in a fraction. In fact, this whole side is one big fraction. Whenever you see one huge big fraction bar, it's a special case. You have to think about this as being in parentheses. We can't get rid of the parentheses or take care of what's in the parentheses until we do the division, order of operations, right? Parentheses, exponents, multiplication, division, adding and subtracting. So even though we would normally get rid of this 3 first by adding and subtracting, because it's in parentheses, even if you don't see them, we have to get rid of the multiplication and division first. So to do that, we're going to get rid of this gigantic division sign, divided by 2, by multiplying by 2. That gets rid of the fraction on the bottom. So when we divide by 2, that gets rid of the bottom portion of our problem. Now all that's left is on the top. Our 3 plus x is equal to, and then on the other side, 4 times 2 is 8. Excellent. So we got rid of the multiplication division. There's no exponents, and then technically, although it wasn't shown in parentheses, it was grouped, so now we can do this grouping portion. Now this 3 has an invisible plus in front. It's being added to x. So to get rid of a plus 3, we do the opposite and subtract 3 on both sides. Minus 3. That's going to cancel this out. And when we bring it down, we get x is equal to 5. Let's plug it back in and check our work. 3 plus 5 divided by 2 should be equal to 4. 3 plus 5 is 8. 8 divided by 2 is 4. Good shape. Okay, let's look at another example. Here we've got a problem that looks like it should be okay, and we treat it like normal, but you'll notice when we get to a problem. So first, I'm going to get rid of this minus 8. We get rid of that by adding 8 to both sides. So far, so good, just like normal. Then we bring down what's left. We still have to make sure to bring down the minus and the x, the negative and the x, because we didn't get rid of it by adding 8. Then on this side, 3 plus 8 is 11. Now you might notice what the issue is. We've run into a little bit of a problem because we have a negative sign. Now remember, there's always an invisible 1 in front of an x. This is like negative 1x. So to get rid of negative 1 times x, you can just think of it as dividing by x, or dividing by negative 1. But I need to divide by the negative to get rid of it. A negative divided by a negative gives us a positive. So positive x is actually equal to a negative 11. You'll notice that the sign switched. So we can't just leave it as minus x or negative x. We have to divide by negative 1 to get rid of the negative sign. Last type of problem that we're going to look at is when we have a fraction. When you notice that you have a fraction in an equation, I'm going to suggest the first thing that you do is rewrite it. And you're going to rewrite it with the x in the top, because this is 1/3 times x. And for multiplying x, you can put anything over 1, right? So if we were to multiply these together, it ends up being x times 1 is 1x. 1 times 3 is 3, so x divided by 3. So you know when you're multiplying, you can just stick this x in the top and it'll be the same thing. So let's rewrite it as x divided by 3. You can think of it as 1x divided by 3 if it helps. So 1x divided by 3 plus 7 equals 11. Now we can solve it without any problems. We have a positive 7, which we're going to want to get rid of by doing minus 7, which we do to both sides. Then we bring down what's left. That's right. What's left is 1 times x, or 1x, divided by 3. This is gone, and on the other side we have 7, 8, 9, 10, 11, or 4. Now, even though this looks like a 1x, a 1 times x, we don't normally write that 1, do we? We don't write it because it's the same as writing just x. So that's actually just x divided by 3, right? So if we're going to do this, the opposite of division is just multiplication. So we're dividing by 3, so to get rid of that, we multiply by 3 on both sides. And what's left is x equals 12. So when you have a fraction, put the x in the top and then just treat it like normal division, which you cancel out with multiplication.